Alrighty, now we got some absolute value inequalities. I love me some absolute value inequalities. It's basically like equations, but a little twist, if you will, just like solving equations and solving inequalities. There's always that little twist. Okay, so the same idea holds true. We're going to set up two separate equations, but in this case inequalities. So if I do that, I'm going to have x and 4, x and negative 4. Now it's going to remain, the first one's going to remain how you see it, okay? But the other one, well, if I think of it as like multiplying or dividing by negative 1, I got to flip my inequality. So this would be my final answer. X is greater than 4 or less than negative 4. And this is an or statement because if you look at it on a number line, let's do that real quick. Here's my 0. Here's my 4. Here's my negative 4. Well, the 4 is open, and it's going to the right. The negative 4 is open and going to the left. This is why we looked at graphing inequalities and graphing and or statements. Apply it right here. Woo! So there we go. They're pointing away from each other, that's an or statement. If they're pointing towards each other, that's an and statement. Let's look at the next one. So same idea. T is less than or equal to 3. T is greater than or equal to negative 3. Let's graph it on a number line. I have 0, 3, negative 3. Well, it's less than 3, or less than or equal to, sorry, so that's a closed circle, and it's going this way. It's greater than or equal to negative 3. Well, what do we have here? They're going towards each other. Okay? So that is going to be an and statement. Cool. There is a way to remember it. We have the absolute value of x is great or, and this is less than. Great or less than. So that when it's like that, it's like this is going to be an or statement because it's greater, and this is less than, so it's an and statement. So, little verbal cues and such. Always fun. Let's solve and graph this bad boy. So we're going to set up two separate ones, as is tradition. 3x minus 4 is less than or equal to 8, and then I have to have 3x minus 4 is greater than or equal to negative 8. Keep in mind, you always have to isolate this absolute value. In this case, it already was, but that won't always be the case. Aight? And there will be some special cases that come up here and there, and we'll deal with those when we deal with them. So let's go ahead and solve these inequalities. I have to add 4, so I get 3x is less than or equal to 12. Divide by 3, and I get x is less than or equal to 4. Other side, we got 3x is greater than or equal to, I added 4, so negative 4. So x is greater than or equal to negative 4 thirds. So there's my two solutions. Is this an and or an or? Well, if I remember my fun little way to say it, less than, this is less than, I know it's an and statement. And you'll also see that from the graph. Let's do it. Here's my 0. Here's my 4. And my negative 4 thirds, which is like negative 1.3 repeating. There we go. It's less than or equal to, so it's going this way. It's this one over here is greater than or equal to negative 4 thirds, and then there we go. So it is an and statement. I can see that from the graph because they're pointing towards each other like that, and I can also remember my way I like to say it, less than, greater. Woo! Let's try another one. Feel free to try and set up on your own, solve it, graph it, and then hit play and watch the explanation. But if you need another explanation, here we go. Set it up into two separate equations. Excuse me, I mean inequalities, not equations. All right, and you'll notice that I had to change this to a negative and this then flipped. Let's solve both of them just like we did before. Alrighty, I've got them both solved. We know it's a greater problem, so it's a great or. So here's my written solution. Now I need to graph it. Here's my 0. Here's my negative 5. Here's my 1. So it's greater than 1. Open. Going to the right. Greater than negative 5, open and going to the left. There's my graph, and I've got my sweetie written answer above it. Questions? You can't ask questions right now, but you can come to class and ask questions. All right, what do we have to do first in this one? Yes, we have to isolate the absolute value. I went ahead and subtracted the 2. So I have absolute value of x minus 5 is greater than or equal to 8. Woo. Now we can set up our 2 separate absolute value inequalities. Alrighty, so now once I've split them up, they are no longer absolute values. I used my absolute value up here to split this up into 2 regular old inequalities. And now I can just go ahead and solve them. I've got my 2 solutions. Do we know what kind it is? Well, it started as greater, so it is an or statement. And now I can go ahead and graph on the number line. I've got my 0, my negative 3, my 13. It's greater than or equal to. Less than or equal to. I got to make sure that's a nice solid circle there because it's equal to. And there's my number line, graph, and my written inequalities. Doing a fantastic job here, kiddos. Alrighty, last one. Let's take a look at it. I can just set up my 2. Wait, hold up here. There's a negative number. I know that's a red flag when I'm talking about absolute values, but let's think about this. Absolute value of 2x plus 1 is greater than or equal to negative 9. What do we always get from an absolute value? We get positive numbers, right? Is a positive number, no matter what number, positive number, going to be greater than or equal to a negative number? Yes, it will always be. Right? Okay, so really we have infinitely many solutions that will work here. Really anything will work here. So we could say infinitely many, or you could say like all real numbers for this one, because really anything's going to work for x. You can also write that as x equals all real numbers. You know, any one of those would be acceptable in this particular situation because anything I plug in for x is going to be working in the original inequality. Cool, awesome, great, grand, wonderful. But let's think about that for the flipperoo. What if this was less than or equal to? Can an absolute value be less than or equal to a negative number? No, because it's always going to be positive. So in that case, it would be no solution. So it's less than or equal to a negative, it's no solution. If it's greater than or equal to a negative, it's all real numbers or infinitely many solutions. Well done.